Example 3 says evaluate the improper integral. Evaluate the improper integral if possible. The integral from negative infinity to 0 of e to the 2x dx. Again, this is an improper integral because we have one of our limits is infinite. So what are we going to do? We're going to rewrite it as the limit as a goes to negative infinity. We always replace that infinite limit with a letter. So this is going to go from a to 0 of e to the 2x dx. Again, I don't know how comfortable you are with your integration, but this is a u substitution problem where u equals 2x, so du dx would be 2 if you take the derivative of both sides, and dx would be du over 2. So what does this look like? Well, we'll rewrite it as the limit as a approaches negative infinity, and this is the integral from x equals a to x equals 0 of e to the u, and then you have du over 2. This is just a simple u substitution problem. Okay, so if I wanted to pull that out, it would be the limit as a goes to negative infinity of 1/2 times the integral from x equals a to x equals 0 of e to the u du. All I did was pull out that 1/2, nothing else has changed. So what's the integral of e to the u? Well, it is e to the u. So this is the limit as a approaches negative infinity of 1/2 times the integral of e to the u. Again is e to the u. It is plus c, but we're evaluating this from x equals a to x equals 0. We need to back substitute for that u. Remember what u was. U was 2x in the original problem. So this is the limit. Sorry, let me use black. The limit is a approaches negative infinity of 1/2. This would be e to the 2x evaluated from a to 0. So let's go ahead and evaluate it. Let me throw parentheses around this for you. This is going to be the limit as a approaches negative infinity of, well, that would be 1/2 e to the 2 times 0, which is e to the 0, which just turns into a 1, right? And then you would have the minus 1/2 e to the 2a in here. Okay. So now what we want to do is think about this. I mean, if you want to rewrite this again, you can. The limit as a approaches negative infinity, and really important we pay attention to that negative here. This should be 1/2 minus 1/2 e to the 2a. So what we need to think about is what happens as a approaches that negative infinity. So think about this exponent approaching negative infinity. And if you want to plug in numbers here, you can plug in numbers into your calculator approaching negative infinity. So negative 10,000, negative 100,000, negative 1,000,000, and that'll help you see what this second term goes to. I'm going to use some logic here. If I had a negative number would have a negative exponent. So the negative exponent here would, 2 times a would be a negative exponent. That would be the same thing as throwing that in the denominator. And e to the 2 times a, that number would be getting bigger and bigger and bigger and bigger. So my denominator is getting bigger, which means my entire thing, that entire term, would be approaching 0. Again, if you're not comfortable with that analysis, that algebraic analysis of a negative exponent and throwing it into the denominator, then just plug in numbers into your calculator. For 1/2 e to the 2a, get numbers as they approach negative infinity. So negative numbers bigger and bigger. So what I'm getting on this one is the first term would turn into a 1/2. The limit of a constant is a constant. Then we'd have minus 0, so I'm getting a total of 1/2. That's what I'm getting right there. The area beneath the curve is 1/2. All right, let's work on our last example together here. Last example is example 4. It says evaluate the improper integral if possible, and the integral is 2x e to the negative 3x squared evaluated from negative infinity to infinity. With respect to x, this one's a huge pain because we actually have 2 separate integrals here that we're going to have to do because we have 2 improper things. So what are we going to have to do? We're going to have to break this up into 2 separate integrals. We're going to look at it as the integral from negative infinity, and we have to choose any point to break it up at. Well, I'll tell you the point that I always like plugging in, the number that's easiest to plug in, is the number 0. So I'm going to break it up at 0. That's any point I could have used, but I'm going to use 0 because I love plugging in zeros. plus the integral from 0 to infinity of 2x e to the negative 3x squared with respect to x. So I have one, I'm going to look at the first half of this, negative infinity to 0, and I'm going to look at the second half of this, 0 to infinity. Now each one of those, I have to treat it as an improper integral and rewrite it as a limit. So look, I'm going to do each one of these as an individual case. I'm going to say the blue one is the first one, and the green one is the second one. So the blue one is the integral from negative infinity to 0. Let's look at just the blue one right now. So I'm going to replace that with a letter, that negative infinity with a letter. So I'm going to say the limit is a goes to negative infinity of the integral from a to 0 of 2x e to the negative 3x squared dx. Okay, so what do I need to use on this one? Well, totally depends on which section you've been looking at. How do I evaluate this integral? Well, it does look like it fits the previous section that we just did, integration by parts. I potentially could use integration by parts on this one, but it actually turns out this one you can't use integration by parts. You would see why if you let u equal 2x and dv equal e to the negative 3x squared. You cannot integrate e to the negative 3x squared. You need u substitution in that problem. So this one actually turns into a direct u sub problem. Let u equal the exponent, which is negative 3x squared. Take the derivative of u with respect to x, you would get negative 6x. So that would tell me that dx equals du over negative 6x. Okay, so I'm going to substitute in for dx, and I'm going to substitute in for u. So I'm going to rewrite this. Go back to my blue writing. This is the limit as a approaches negative infinity. I have the integral from x equals a to x equals 0 of, well, it would be 2x e to the u, and then I'd have a du over negative 6x. So again, this is an integral from the u substitution section if you need to look back up how to do this. My x's are going to simplify. Negative 2, 6 simplifies to negative 1/3. So I'll pull that negative 1/3 out. This is the limit as a approaches negative infinity. I pull out that negative 1/3. I'll be left with the integral of x equals a to x equals 0. Well, then it would be e to the u du. Okay. I'm going to keep on going. Not saying this is easy. This is the limit as a approaches negative infinity of negative 1/3, which I technically could just pull that negative 1/3 out in front of everything, but that's okay. E to the u du, the integral of that is e to the u plus c. But again, this is evaluated from x equals a to x equals 0. I need to back substitute for u. U was negative 3x squared. So this is the limit as a approaches negative infinity of negative 1/3. This would be e to the negative 3x squared, evaluated from a to 0. Whew. So this equals the limit as a approaches negative infinity of, let's see what we could do. It'd be negative 1/3 times e to the negative 3 times 0 squared is my first one, right? And then I need to plug in the lower limit, so that's negative 1/3 times e to the negative 3a squared. So this equals the limit as a goes to negative infinity of, well, e to the 0 is just 1, so this would be a negative 1/3. And then on this next one, I'd have plus, and then I don't know how you want to look at it. It's totally up to you. I'm going to look at it like this, just to kind of help me understand what's going on. This would be a 3e to the negative, or sorry, now it would be a positive. I'm throwing it into the denominator. So this would be a 3a squared. Okay. So now let's think about the limit. The limit of 1/3, negative 1/3 is 1/3. That's fine. Let's think about as a approaches negative infinity of this term right here. So we do have a squared, so that number would be positive. So this denominator of the second fraction is getting huge. And if the denominator is getting huge, the fraction approaches 0. So it seems to me the first half of this problem, I'm getting a limit of negative 1/3. Negative 1/3. Okay. There's a lot of work, and we only did half of the problem. We only did the blue part. So now we need to go in and do the green part. Let's go in and do the green part. So the green part is the integral from 0 to infinity of 2x e to the negative 3x squared. So we're going to replace that infinite limit with a letter. So this is going to be the limit as b approaches infinity of the integral from 0 to b of 2x e to the negative 3x squared dx. So what's the nice part? We've already done this integral, so we already know what this integral ends up being. I'm going to go ahead and jump. Let me show you where I'm looking right here. I'm looking at this one right here. This is when we did the integration. When we integrated it, we ended up with negative 1/3 e to the negative 3x squared. So when I evaluate this integral, I'm going to have the limit as b approaches infinity, and then I'm going to have negative 1/3 e to the negative 3x squared, but my new limits are 0 to b. So let's give this a try. This is going to be the limit as b goes to infinity of negative 1/3 e to the negative 3b squared. That's when I plug in the first one minus, and this is negative 1/3 e to the negative 3 times 0 squared. Which is going to be e to the 0, which is just a 1. So this is going to be the limit as b goes to infinity. I'm going to clean it up a little. Because it has a negative exponent, I'm going to go ahead and throw it in the denominator. This is going to be negative 1 over 3b to the, 3e to the 3b squared. I moved it to the denominator, so I made the power positive. And this is going to be plus, well, it's all that stuff turns into a 1, so this would be plus 1/3 because I was subtracting a negative. Let's consider when b goes to infinity, that exponent would get larger and larger, which would make the value of the denominator larger and larger. And if the denominator is getting bigger and bigger, the fraction goes towards 0. So it looks like I'm getting a 0 plus 1/3, which is what, 1/3? So there it is. For the first half, I got negative 1/3. For the second half, I got 1/3. So if I look at that original integral, I have negative 1/3 plus 1/3, which is a total area of 0. So it does converge. What's the area beneath the curve? The answer is 0. What in the heck just happened? Well, here's my thought about it. Most likely what happened is we have just as much area above the curve as we do below the curve. And remember, when we find the area below a curve, we get a negative answer. So let's say the top one, well, I mean, that's exactly what it was. The top one, those above the curve gave us an area of 1/3. Those below the curve gave us an area of negative 1/3. It was still an area of 1/3. It's just that it's below the axis. So when we put them together, we have just as much area above the curve as below the curve, which means it cancels each other out, and we get a total area of 0. Kind of a cool problem there. A little bit of a pain in the butt, but you know what? We can do it. Break it into two separate integrals, integrate the first part, integrate the second part, add those two numbers together, and you have the integral of the entire thing. So there's 4 examples for you. It's really ended up being 5 or 6 examples for you if you look at the different parts. I hope that helps you with the limits of integration. Expect 1 or 2 of these on the test. Certainly you need to know when you have an infinity or a negative infinity as a limit of integration, you replace it with a letter, you integrate like normal, and then you just take the limit as that letter goes to infinity or negative infinity. Hope that helps, and congratulations on finishing the semester.